Welcome to Study Loop.
So we have a carbon-14 dating problem, and we're going to use our radioactive decay model, exponential model, m equals m naught e to the kt. Initially, we're going to use the half-life information to find the value of k, and then once we know that, we'll be able to answer the question. So for the half-life, we're going to use m naught as the initial amount, and then we can use half of m naught as the final amount. Put that into the equation, and we put the half-life in for the time, and we can solve for k. So those are the numbers plugged into our model. So let's divide both sides of the equation by m naught, and we get 1/2, which I'll just write as 0.5, equals e to the 5,730k. Now we take the natural log of both sides, and we divide both sides by 5,730, and our value of k is the natural log of 0.5 over 5,730. So that goes into the model, and now our model is m equals m naught e to the natural log of 0.5 over 5,730 times t. So we're going to use that model as we move forward. So now we know that the sample of parchment had 74% of the normal amount of carbon-14 in a living plant. And so 74% would be 0.74 times m naught is the amount that's in there. So we can substitute that in for m, and we'll solve for the time. 0.74 m naught equals m naught times e to the natural log of 0.5 over 5,730 times t. We divide both sides by m naught, and we have 0.74 equals e to the natural log of 0.5 over 5,730 times t. Now we take the natural log of both sides. So we have the natural log of 0.74 equals the natural log of 0.5 over 5,730 times t. And our goal is to isolate t. So let's multiply both sides of the equation by the reciprocal of this fraction. And we end up with t equals 5,730 times the natural log of 0.74 over the natural log of 0.5. We put that into a calculator, and we end up with approximately 2,489. So that tells us that the parchment was, according to this method, 2,489 years old.